Before we get into the main topic of this video, if you don't know how floppy drives interface with a computer, you might find it beneficial to go back and watch my video talking about a 4-floppy controller for a PC. Because what I'm talking about today is kind of along those lines. I have developed something that makes the process of using multiple floppy drives in a computer much easier. And it works in a really interesting way because it just about couldn't be more simple to use. And I'm going to go over how you can make one of these, how you can use it in a lot of interesting ways, and well, we'll talk about some of the interesting ways that it's actually natively supported by DOS that you've probably never even heard of. Because today, I'm introducing my Floppy Switchboard, an extremely simple, totally passive device that allows you to connect pretty much an unlimited number of floppy drives to your computer. So, this is an incredibly simple device that allows you to switch between 2 different floppy drives with just a bare mechanical switch. No software, no fancy controllers, nothing. Now, why should you care about this? I've already done a video showcasing that you can get floppy controllers that allow you to connect up to 4 floppy drives, which covers pretty much every use case you could possibly want. But that's on a PC and doesn't actually cover every use case. So one really simple example are flux imaging devices like the Grease Weasel or Cryoflox. Now, these use the PC style floppy interface for the floppy drives because PC floppy drives are the easiest to get a hold of. But that means that they support at maximum 2 drives, which means that you can't have everything you want connected to them at once. Although even with this, you still really can't, but we'll get into that, and that's part of why I have 2 of these now, more than just I wanted to test out the Grease Weasel after the Cryoflux. But let me talk about how this thing works first, because it's just so blindingly simple. First off, there's an error on the silk screen. And I only mention that because this thing is open source and you can go to the GitHub repository right now and clone this and make your own. I am currently undecided if I'm going to be selling these because, I don't know, it's pretty simple. I don't think that it's really necessary, but if there is a lot of interest in that, let me know in the comments, and perhaps I will do that. It's been a while since I've done the PC Junior kits, just because it ends up being a lot more work than I'm really able to take on all at once, but perhaps I'll get back into that. Now, the thing is, PC floppy drives are controlled with 2 signals. They are the motor select and the drive select. Now, the motor select, as I talk about in the 4-floppy video, is just a repurposed drive select. But the thing is that it's just those 2 signals. Those are all that changes. Every other pin on the floppy interface is connected to all the floppy drives at once. So if you're able to connect or disconnect the motor and drive select signals, you can interface with different floppy drives without interrupting them with other drives. So when it comes down to it, all this thing does is allows you to disconnect or reconnect the motor and drive select signals to different floppy drives. That's it. It takes one floppy interface here and allows you to mechanically switch between one of the 2 headers on here, receiving the motor and drive select signals. Now, there are 2 headers here, and this revision of the board has a mistake. I will correct this in the repo here, but these 2 need to be swapped. This describes whether or not the adapter is being placed before or after the twist in the cable, because that is how the drive select is done on a PC style floppy connector, and it will depend which motor and drive select signals you flip. So these 2 headers here are used to connect the cable, which is a standard DP-DT double throw, double pull switch, to these connectors. Now, this is actually part of why I'm not sure I want to sell these. I can't find these pre-made, and I'm kind of tired of making cable assemblies. These are really a pain to do a bunch of. So if someone can find one of these that I could include with a kit or point to, I'd be a little more inclined to actually sell these as a kit, because that takes way more time to make than you would think it does, because it's just kind of a pain to make cables. So you plug that in to one of these, and then the switch just literally chooses one of these drives. That's it. Yeah, there's not a whole lot to explain here. We're not gonna draw out this video because that's it. But you should see this in action. So let's take a look at a couple of different use cases on why you might want one of these. First up, my test bench. This is still one of my favorite computer builds I've done because of just how extensible and easy to work on it is. I've been using this off and on in some of the streams that I do on Twitch, and it's just been fantastic. But one of the things that I did kind of early on after I made the initial video was create the floppy switchboard, and I have one mounted right there. And this is actually part of why this video is actually taken so long to make, because mounting that thing is kind of not easy. I added 2 mounting holes here, but they don't really line up with anything. So I've been trying to think about, hey, can I make this mount to the side of a 3.5-inch drive, maybe next to something else? And it's just been kind of a pain because it's really a little big and has a lot of contacts to just be flapping around loose in a computer case. So I've been able to figure that out, but I decided it's just time to make the video and get it out there because I've been using it and I want to talk about it because I have some other use cases for it. So I have it in the test bench here, and the reason I have it in here is so that I can have both a 3.5-inch floppy drive and a Gotek, and I have my Gotek's display output actually connected to this little display right here. Now, a Gotek on the test bench just makes way too much sense. I can take a flash drive here with a different DOS boot disk, plug it in, turn it on, and it will go ahead and boot into that if I select the Gotek. But there are times when I want to be able to use a real 3.5-inch disc, and I'll want to switch over to that and be able to put one of those in. And I could theoretically do both of these if I didn't also have a 5.25-inch disk drive connected, but I feel it's important to have that in there because it makes it more all-purpose. This is not for disk imaging or anything like that, so I just have an 80-track drive in here, and it's able to do everything I want. So the floppy switchboard allows me to have both the 3.5, 5.25, and emulator drive in here without needing to change any cables or anything. And this is also important because I could, of course, have a 4-floppy controller in here to do that, because the motherboard up in this computer is not necessarily always going to be the same. So having a custom interface to the floppies instead of a custom floppy controller makes this thing a little bit more compatible as a chassis instead of as a system. Okay, so let's go over the most basic use case of this, which is what I did in the intro without really talking about it because it's just that easy. So first off, we'll do a dir A, which is going to attempt to access the Gotek, see no drive, and fail. So we're going to do this. We're still on drive C, and I'm going to plug in the flash drive. Now the Gotek's going to find a disk image on there, load it up, and now if we rerun dir A, we will see I have a DOS 622 disk available. But if I flip the switch, put a 3.5-inch disk in, and then run exactly the same command, it will access that drive and find a FreeDOS installation disk. So that was really, really easy to switch between the 2 drives. However, there are some peculiarities with using this, because if I flip the switch back down now and rerun the same command, you're actually going to see the FreeDOS disk again. This is because DOS caches the drive file index, so it doesn't have to rerun that again. It's just the same kind of thing as when you run dir on something like a 5150 and it has to calculate the bytes free the first time. It's caching some information about the file system so that it doesn't have to rerun that every single time. Now, one of the ways that it knows to refresh this is when it receives a disk change signal from a drive. So if I disconnect that, rerun dir A here, it should now find no disk, fail. All right, flip the switch down, rerun the command again, and it's going to refresh and get the DOS 622 disk. So you can force it, but it's a little messy. Now, where this gets extremely interesting is the fact that DOS actually has the ability to support this built right in. As I was researching this all, I found this just absolutely fascinating because under the DOS directory in your default installation, you will find a program called driver.sys. Well, program, it's a driver file, but driver.sys is the most generic file name you could ever possibly have, and it's really hard to find information on this thing. But what this is almost exclusively designed for handling this exact use case with one of these kinds of floppy adapters. And because it's so rare and hard to find documentation on, I've actually included some on the back of the board. So let's take a look at that. Now, the way that driver.sys works is by adding it to your config sys as a device line, you can add additional virtual floppy drive interfaces that your computer will then present to your software and available to be accessed through command prompt. Now, that's pretty much it. You choose which actual physical interface you want to use, and then you tell it what the drive configuration is. And there are different drive configurations available for the different kinds of common floppy drives. So really, it's actually very easy to add more types of floppy drives, and they will be presented with unique drive letters. It also handles the disk changing for you. Let's go ahead and add one of these and you'll see exactly what I mean. All right, I'm going to edit config.sys and I'm going to add a new device line, device equals C. I'm gonna reference my board here, driver.sys. Now I'm going to add a device at drive index 1, which should match the end of the cable, and I'm going to tell it that it is a format 7, which means it is another 1.44 megabyte drive, and that's it. I'm gonna go ahead and save that, quit, and reboot. So that should be it. All right. Now, as DOS boots up here, we will see a new line right there. Loaded external disk driver for drive D. Our new virtual floppy drive has been added as drive D, which is really cool because we can now just access it that way. Now, I don't know why it's called external disk driver because we're using an internal port. I mean, the number, literally, the interface is internal, not external. Those would be what the 3 and 4 floppy drives are on a 4-drive controller. But I don't know. Let's just not worry about that right now. Now, as far as the operating system is concerned, we have 2 actual floppy drive interfaces, but on one of them, we have 2 floppy drives connected, and it does know this. But there is no way it can know which is which. So it's going to be on us to arbitrarily designate which one of these is the real drive A interface and which one is the drive D virtual interface. So I'm gonna say here that the GoTech is the real A interface and that the physical drive there is the one that is accessed through D. So let's go ahead and try this. I'm going to dir A. And because there is no drive in the GoTech, it's not gonna find anything. So I'm gonna go ahead and fail that out, and I'm gonna plug this in, rerun the command, and now it will get the DOS 622 disk contents. Next, what I'm going to do is I'm going to put this disk in. It doesn't really need to go in right now, but just why not? And then I'm going to run dir D. And we see this. This is the best part about this driver and why I think that DOS was actually designed for something exactly like this. This is giving you a moment to get it ready. This is only needed because you have to flip the switch. And then it also knows that it needs to refresh the drive index, or the file system index, I should say, for what files are on there. So now when I press a key, it's going to access drive D here, and we see the FreeDOS disk contents. If I go back, dir A, it'll do the same thing. Give us a moment to flip the switch, and now it knows to refresh the disk contents. DOS 622. We have completely avoided the issue where the change disk signal is not being sent because it knows it needs to refresh it because it's accessing two different virtual drives over the same interface. How awesome is that? It's seriously, again, it's like it's designed to use one of these, and this is just built into DOS. I'm not sure how far back it goes. I have not checked that, but it's definitely just included with DOS 622. Unfortunately, it's not included in Windows 95 and 98, and definitely not the NT Windows. And the driver.sys is locked to the exact kernel version of DOS that you're running. It's not compatible with, say, an older version. I can't get the driver.sys from 622 to run on the 7.1 from Windows 98. I haven't been able to get it to work on FreeDOS at all, which does not have an equivalent. So if you want to use something like this, you're kind of locked into the specific versions of DOS that include it. But it's pretty awesome that it works at all. And let's be real, on Windows 95 and 98, you probably don't need a bunch of weird virtual drive interfaces because if you're doing anything with tons of floppy drives on those, you're probably doing disk imaging, and you'll have tools that will allow you to specify what the drive structure is independent of what the BIOS tells you it is. On that though, let's check out using this with disk imaging hardware, because this is one of, if not its best use cases, because this is just great. Okay. Here we have a bundle of 3 floppy drives I've put together. We have a 40 track 5¼ inch drive, an 80 track 5¼ inch drive, and an 80 track 3½ inch drive, which realistically is compatible with pretty much everything, so we only need that. But that gives us 3 different drives, and neither one of the disk imaging devices I've tried can access more than 2 drives. So something like the Floppy Switchboard here is the only way to be able to access all of these drives. Now, this is really easy because the software interface for both of these pretty much has you configure the drive configuration every single time you go do a disk image. So it's not keeping track of anything and measuring how the files are structured and all that stuff until you actually use it to rip a disk. So having the drives change between uses doesn't matter at all here. So a completely passive adapter like this, totally fine. So how on earth do you connect something like this? Well, first off, I've got a bunch of adapter cables here for power. That way I can plug in the 2 4-pin Molex connectors for the big drives and the Berg connector for the 3½ inch drive. Now, this is where my straight through cables here kind of fail me because I don't have the card edge connectors crimped onto there yet. I think I do have some, but I don't have a vise here, so I can't easily do that, and I don't have the proper crimping tool, which is not the most easy thing to get a hold of. So I'm going to be using regular floppy cables and just kind of ignoring the bit after the first one. So we're going to split the 2 5¼ inch disk drives here. So let's go ahead and put the cable on one down here. And we're going to put this one on here. Now, we do have to get these connected to the switchboard. And you'll want to pay attention to the pin 1, just like normal here. You can mess that up. And then we will have one more cable here that will go up to the 3½ inch drive there at the end of the cable. We can plug this in. Actually, we're going to plug this into the card edge slot here. So yeah, this is the thing. The floppy switchboard has a card edge connector, so you don't have to put in the 3½ inch connector. But if you want to be able to connect like that right there, then you could solder that on. But for most of the time, I think you're going to be able to get away with just doing that. But there you go. Now we are before the twist on here, so I'm going to put the jumper on the section marked for that, which again on mine is actually backwards. I will fix that before I release this video. So that's it. And now this should switch between the two 5 1/4 inch disk drives. It's not super complicated to set up. It's just, you do have to set it up the right way, and that's kind of a lot of cables. Again, you could clean this up a lot if you had card edge connectors crimped onto straight cables. I just don't at the moment. Again, one of many little things that have been dragging this video out that I'm just deciding to push through. So I'm gonna power all of the drives, and I can do that at once. I just have a really simple external power adapter that has a Molex connector. It probably came with some IDE hard drive reader. And for right now, let's go ahead and try the Cryoflock board. So I'm gonna plug this in like that. Actually, you're technically not supposed to power the drives before you power this, but it doesn't make that big of a difference. Okay. The Cryoflock software is a little easier to demonstrate this with, so I'm going to go ahead and launch that first. So the reason that the Cryoflock GUI is a little easier to use here is because it has a calibration feature which just checks how many tracks the head can reach. So we're going to do drive 0 first, and we're going to calibrate here. So drive 0 here is the 3 1/2 inch drive. That's working correctly. So it sees 83 tracks at max because the head can go just slightly past, but that's normal, so that worked. We'll go to drive 1, and this is currently set so that it will access the 80 track 5 1/4 inch drive. So let's calibrate that. Light to light. And now that's moving. Perfect. And now all I'm going to do is flip the switch and then rerun the calibration, and it will find the 40 track 5 1/4 inch drive. There we are. We accessed all 3 drives, and all we had to do was just flip one switch. Now, this same thing also works with the grease weasel. So if I swap this out, there we are. I can launch the Flux Engine GUI. All right, and if we did drive 0 there, I can go ahead and put a disk in here, and we can image that. What was this for? That is for the IBM. Perfect. Drive 0, that is not a high density disk. And we will read Flux. It will select that. So there we have a successful read on the 3 1/2 inch drive of, ooh, exciting, easy working resume creator. Yay! But we can switch over to the 5 1/4 inch 40 track drive for this totally original copy of 13 Ghosts for the TRS-80. Lock that in there. Go over to drive 1. Now again, this does not have the calibrate feature like the Cryoflock software does. There's probably a way of making it spin the drive or something that I just don't know of offhand. And there's also the Flux Engine. Well, actually, this is a Flux Engine software. That's right. The Grease Weasel software has a custom command line tool, but the Flux Engine just happens to be compatible with it because it just makes life easier. So we're going to set this drive 1. We're going to set the format to TRS-80 somewhere here. Does it not have TRS-80? I think it's kind of IBM-like. Let's just try that for right now. Then we'll read the Flux, and I'm pretty sure I already have that one selected, so let's go ahead and try that. Boom. And there we are. We have both drives being accessed. This is single-sided disk. So that's not unexpected. A lot of TRS-80 software was single-sided. It is going to make it take a lot longer because it's retrying each side 5 times. So let's just go ahead and stop it. We verified that worked, and what we could do, take the disk, move it up to the other drive here, flip the switch, and test that it'll work in there as well. You can read on the 80 track drive. Perfect. Working great. Oh, you know what? I know what it is. It's single stepping. It's reading garbage data in between the good tracks. Yeah, again, this is why you want a 40 track and an 80 track drive. It gets really confusing because every other line is bad on this. So yeah, don't worry about that. Well, all right. There we are. That is the floppy switchboard. It's really simple. It switches floppy drives. I am actually using this quite a bit, and I have a bunch of PCBs made. Again, I don't know if I want to sell these. It's really simple. It would be so cheap to get them made yourself as well, because you literally need one 40-pin link dual row header, because it's two 34 pins and then two 6. So it actually is super easy and cheap to make one of these yourselves if you want. You can just download the Gerber files from the GitHub repository, because this is open source. I'll link it down below, and send them off somewhere. But yeah, if anyone wants one of these pre-made, do let me know and I will consider that. But that is it for now. If you have any other questions, feel free to ask them in the comments, because this thing is somewhat simple and straightforward. I don't think there will be many, but yeah, just let me know. Or make an issue on GitHub. I will have to fix that silk screen on these before I release this video. Yeah, if you do have an idea of a better way of mounting this, something, you know, along a drive or in the case somewhere, let me know. I keep saying like next to a 3.5-inch drive, because the thing is that if you mount it like on the back in a PCI slot, the cables you need to connect the drives will have to be super long. They're going to be running all around the system. So I would like to keep it near the drives, and then the smaller it is, the easier it is to integrate into weirder devices. Now, I mentioned that it's not compatible to everything, and one such example are these. Back here are two 8-inch drives that came with my CPM 100 computers. This cannot switch between multiples of those, because those use one of the 4 Shugart interface drive select IDs. This moves 2 of those at once, so you'd end up selecting multiple drives at a single time and it wouldn't work out. So that's actually why I'm going to be setting up this system. This whole computer desk area I've got right here is actually going to be my disk imaging center, and I have to use both the Grease Weasel and the Cryoflox, because one of these has to be connected to the CPM drives and one of them has to be connected to the PC drives. Elsewise, I would have to create another one of these types of devices that switches all of the drive select IDs, which is possible, but would need a much more potent switch than that, and these are already hard enough to find as it is. So I don't see that happening. Keeping it really simple here by just switching 2 lines at a time instead of 4. The other way you could do it is having a bank of dip switches where you just flip them on one at a time, and then you could mark which 2 pairs are the ones for the PC type drives. But that requires a lot more user thought, and the idea here was just flip, switch, drive, change. So that's it for now. If you guys enjoyed this video, again, definitely check out the GitHub repository, because you can get everything to make one of these yourself there. But if you enjoyed this one, you might want to subscribe to the channel, because I have more custom electronic stuff coming up that is way more exciting than this is, at least for me. Probably no one else will actually be able to use it, so that's fun. But yeah, if you want to help support the channel, I am on Patreon, or you could buy some merch that's linked below. But that is it for now, and I will see you next time.